Good morning, Kobe. Kobe, can you hear me?
Yeah, sorry, somehow it got muted, So how are you doing, Sami?
I'm doing good. How are you?
Oh, okay. Yeah, it's been hectic, so.
I understand. Good morning, Babak.
Hi guys, I'm in the train. Sorry, being late.
That's okay. I'm just we're just assembling.
Yeah.
I'm waiting for Danny and Jeff. Hopefully, they will be able to join soon. While we are waiting, any opens? And Babak, probably you might have got a notification like one panel got approved and one got rejected.
Yeah, I got that. So, is it possible to know earlier what day the panel will be on?
I think they are forming the calendar. I can check and let you know. Yes.
Yeah.
I believe sustainability track is going to have a whole day track. So I'm not sure whether it's scheduled for second day or third day. So I will check and let you know. Yes.
Okay, sounds good. Thank you.
Hello.
Hi, Shankar. And hi, Savita.
Yeah, hi. How are you?
Good. How are you? Do you have any opens? Either Savita or Shankar?
No, I mean, I just joined this week, so I can give a little bit of an introduction.
Yes, we would love to hear from you. I think, yeah.
Right. So I'm based out of SLAC National Laboratory in Stanford, Material Science and Engineering, and I'm leading the efforts in SLAC on sustainable computing and energy efficiency in computing. So that's probably why I referred to this meeting. So that
Good. Thank you for joining. In fact, I think that is another area really like need to influence to make changes. I think thanks for joining. I think it's like Babak, right? It's good to have academia participation here.
Yes.
Hi, Swami. Yeah.
Hi.
Hi. Yeah. I can introduce myself too. This is my second meeting. Yeah. This is Savita, and my background is in sustainability. I used to contribute as the IT and data center sustainability strategist at Credit Suisse UBS, and I just moved to the Bay Area, so exploring the data center world here to contribute more towards sustainability. Happy to happy to contribute in any way I can help any of you folks in the sustainability space here.
So I had actually a question, maybe for Sami and the group, is the fact that do you know where is there data publicly available for data center growth and all that you are aware of?
Yes, I believe if you look at the regional summit presentations, I think there was some presentation from, I don't recall exactly like which research institute published the numbers. I believe there was presentations with a lot of information about different growth and different areas and where we should be targeting on sustainability.
Okay. Where should I look for again? Sorry, Sami. I mean, I'm
No,
new to
that's fine.
this.
That's fine. Let me quickly do a quick look up on the OCP site and give you the link.
Right. So I can send you two of my papers in which I have done quite a bit of analysis. So if you, I mean, feel free to circulate it. I can either send it to you or put it on the chat or whatever.
Yeah, you can put it on the chat, and also if you can respond to the mailing list, then because
Sure.
people who have not
So that may be easier because people can click on the mailing list. I will respond to your email. Okay. Okay.
Is there a wiki page, Sami, that where we upload the discussions and that happen on this group?
So what happens is the every meeting is getting recorded, and as part of the recording, OCP publishes that in a YouTube channel. And I have not tracked specifically like any special link. So it's the presentation's link comes in the posting mail, but previously like the leads need to upload or send the link out to the post. But recently they changed to publish every single meetings to YouTube channels. I also probably need to look at exactly what is the channel tag. Probably I'll take a look and send a note to this group too.
Okay, thank you, Sami.
Thank you.
So Sadas, did you say that you have your own stats about data center growth?
Yes. Well, not data center. What I was saying was the other. I have a lot of other data, but not on the data center at the higher level.
So you have data about what?
So I have data about AI ML accelerators and energies they use, supercomputers and the energies they use, scientific computing and the energy it uses, crypto coin and the energy it uses, and then natural language processing, training, and ChatGPT and the energy it uses. I have all that data, and those are all published information.
Would love to see that. That'll be good.
Okay. Yeah, I will respond to Sami's email and attach the links.
Sure. I just posted the link for the regional summit.
Okay. On the chat?
Yeah, on the chat.
Okay.
If you click the link, it takes you to the 2024 Lisbon, all the presentation and some videos.
Okay.
I don't recall exactly which particular presentation it had, like some of the studies. I remember reviewing some of the materials before it was presented. So,
I see. Very good. Thank you so much, Sami.
Sure, no problem.
So I will also be sending you before, I mean, as soon as this meeting is over, I will send you all the links.
Yeah. That's fine. So any other opens? I was hoping.
Nothing from my end, Yeah. So yeah.
Okay. Yeah. So maybe we three of us probably like introduce ourselves to Savita and Shankar, so it'll be good. So I'm Simon Achimuthu. I'm part of Intel Corporation. I've been with Intel for more than 30 years now. Right now, I'm chairing this DCEM work group. And also in OCP, I lead the open system firmware or open platform firmware project, and also co-chair cloud service model in the OCP. And within Intel side, I work on the server systems architecture, especially mostly spending a lot of time on the firmware side. Good, Gopi.
Sure. My name is Gopi. I'm a senior technologist, principal engineer, working on mainly the, Department of Defense and all the system integrators like Lockheed Martin, Northrop Grumman, BAE Systems, Army, Navy, and beyond. And my experience over a period of like 40 years is in the area of server architecture, workloads, performance modeling, power optimization, simulation technologies, and AI solution development for various usages. And I worked on data centers long time. So building the whole, huge models, TCO models, and with all the power, performance, and type of architecture that needs to be developed for future. Yeah.
Thank you, Gopi. Pavak, you want to introduce yourself?
Maybe the train or something, probably. Okay.
Looks like you're on mute, Pavak, if you're talking.
Yeah, I'm in a tunnel. Sorry. So Babak Alstafi, professor of computer science at EPFL in Switzerland in Lausanne. I was a full prof at Carnegie Mellon before moving here 16 years ago. I am also the founding president of the Swiss Data Center Efficiency Association, where we have a platform called SDA Navigator for DC energy flows, for IT energy flows, and also for operational emissions from the sources of electricity. I've been doing server architecture for 20, 30 years now. I think some of our work is now part of actual products. One of the latest we did was the first server-grade ARM CPU design, which was picked up by Cavium, the first generation of Thunder X, comes right out of my lab. So.
Yeah. Is Babak the way to call your name, or am I?
Yes, that's my first name, and it is Babak. You could call me Babak. Yes.
Okay.
And I've been, by the way, working with Intel since 1998 when I started my career. So I have a lot of friends at Intel as well.
Yeah. So Babak, I have a good friend in EPFL, Nicola Marzari.
Yes. Nicola is yeah.
Yeah, I'm on a scientific advisory.
Excellent.
Yeah.
It's a small world.
Small world, yes. Yes.
Good. Thank you. So originally, like I was thinking of, Danny and Jeff indicated that they want to come and present their telemetry work streams, some of the work they have done to our groups to get some acceptance on some of the metrics or telemetry data they're collecting from our group, because we are one of the consumers of the data that is coming out of the telemetry work group within the sustainability.
Sorry, what group is this?
So within the sustainability, there's a work group called telemetry.
Sorry, I'm probably mishearing.
Yeah, I will give you the link. Hold
Okay.
on.
So this is Intel based, or?
No, it's OCP based.
Oh, okay. OCP, right? Or
Right.
yeah.
So I pasted the link here. If you basically look at the Let me share. It might be helpful here.
Oh, it goes into sustainability link in the OCP, right?
Correct. So sustainability has multiple work streams underneath.
Oh, I see. I see. I didn't realize it looks very, very complicated.
Yeah. So in the
Outside.
sustainability main link, then at least they are not probably putting all the names of the
Oh,
work streams, but you have to click this page to see
I
all the
got
work
it.
streams underneath.
I got it. I got it. Do you have, I mean, do you have any write-up or presentation on the metrics for data center efficiency, Sami?
So one that we presented that I have that link in the materials.
I see.
Let me look at here, right? So the previous link I sent out before,
Okay, the same one.
that was yeah. So that is one that we presented regarding IUE work that we are doing. And what we have basically they said was when we started the work stream, like probably like a year back,
Okay.
let us first look at the PUE and what are the issues within the PUE.
Mm-hmm.
And then let us define something new or something to augment PUE so that we are measuring from within the data center
Mm-hmm.
IT workloads rather than coming from the grid.
I see. I see.
That's the basic work we have done. And right now, what we have done is last, I don't know, 7, 8 weeks, more than that, all the work that we have done, we are trying to kind of define some of the terms and like how do we collect them data from the systems and how do we able to connect them together.
Uh-huh.
It's an work in progress, and I would like to really like get that written down. It's written down, but it's not like kind of ready to kind of
That's okay.
consume.
That's okay. That's okay. But is there any, the main reason I am asking is I'm trying to put together a write-up on the data center aspects, specifically with the AI in mind, because that's one of the biggest drivers these days. And was wondering whether there was something I could use your work as a reference or so. That was the reason I was asking.
Yeah. So for that AI related things, if you look at that the regional summit link I send you,
Uh-huh.
there is multiple tracks underneath people presented.
I see. I see. Okay.
If you look at all the materials, there's a lot of talk about AI consuming so much power in the data centers and how that need to be addressed and things like that, right?
In the presentation,
And
the link you sent.
correct.
Okay.
So I put 3 links here, right? First link is the one, it's a regional summit link.
Okay.
And the second one is a sustainability project. And third one is our work that we have done.
Okay. Okay. So I can refer to that presentation.
Right, right.
Okay. I just want to make sure I'm referring to the right documents.
Right, right, right.
So
So
you get the
since that
acknowledgement.
presentation, what we have done is we are kind of firmed up on the terms. And the terms I need to publish, I think that I have not done that publication yet.
Mm-hmm.
In fact, what I'm want to do is want to create a white paper to kind of say what is the IUE and how the definitions and everything connected. That's why we were having a lot of brainstorming sessions last few weeks to kind of firm up on the terms.
Okay. So you may want to look at the 2 papers that I will send the links
Sure.
to you, because there we took a lot of efforts to get the metrics for measurement at system level. but it doesn't do it totally at the data center level yet. And that's what we are trying to do. So it will be good if there is some.
Yeah, actually, we need both. But we are realizing is if you measure at data center level, how are you going to influence? In fact, that's a second topic I want to do a brainstorming today.
Right.
But we are really looking at is if you look at PUE, the way it is defined is trying to look how much energy is coming into the data center.
Mm-hmm.
And before going to the IT equipments, all the non-IT, all the energy that is gone to cooling or power conversion, that's the only thing they're considering it.
Mm-hmm.
But after that, it is up. They're considering the whole thing as a data center. I mean, IT energy.
Mm-hmm.
So in fact, maybe this is the right point that we could start the discussions there.
Yeah.
What we are trying to influence within our work stream is how do we go further, right? So I think, sorry.
So one of the things that corporates are doing, which I've seen in UBS and in Credit Suisse as well, is I think there's measurement of power consumption and hence carbon emissions for different for different data centers. But once we have figured out the carbon emissions for data centers, there are several efforts that are going on to reduce the carbon emissions and power consumption. So there are efforts like green coding that Credit Suisse does effectively, where because they have a lot of applications, like homegrown applications, they try to individually reduce the software emissions of each one of the application, and hence efforts are being done to reduce the carbon emission at a software level, then different efforts to reduce it at heating and at the cooling level. So basically, I think there is no, I mean, what I've seen practically is there are several small efforts to reduce it individually and then see how it contributes towards the overall power consumption. That's one of the things I've seen. Yeah.
That is true. That's where I think what we have to kind of look at our work stream here.
Yeah.
We are leaving carbon to be addressed by the carbon work streams, right? I think if you look at the sustainability, under sustainability, we have a carbon work stream.
Okay.
And I think you can see like 3 different carbon work streams, right? Right?
Yeah.
And we are leaving the carbon to be addressed by that 3 different work streams within that sustainability. And power and telemetry work stream is trying to collect any data that need to be collected from the systems. And the DCEM work stream, what we're trying to do is how do we connect those dots together, right? So instead of focusing on carbon, we are trying to focus on power, and we are trying to focus on performance, at least initially right now.
Okay.
That's where I think.
Would it help to like build out a calculator for power to carbon emissions? Like, will anything like that help you? Like, I can help building something like that.
In fact, there was a calculator project done by Eddie. I think he left until there was another work stream was going on a calculator side. I think we need to think upon that.
Okay.
So SDA
Babak,
in
you want to say
Switzerland,
something?
yeah, we have a calculator. So we've launched a navigator as of last week. We have 3 calculators. We have one for the DC energy flow. Our DC energy flow is not PUE. It also takes into account heat recycling, and it takes into account on-premise renewables. We have an IT calculator, and we also have an emissions calculator based on source of electricity. And the emissions calculator has, right now we have a government of Switzerland published data about the sources of electricity and their emissions, but we also have a service in Europe that is now connecting online grid information and their emissions, and our calculator is connected to that service as well.
I'm guessing it's custom built for your systems, right? Yeah.
The DC calculator and the IT calculator is worldwide. Anybody can use it. The emissions calculator has the current table based on published information from the Swiss government in Switzerland.
Okay.
These numbers don't really change that much. I mean, if you look at the source of, how much emissions you get from nuclear, how much emissions you get from hydro. But yeah, there could be variations, small variations. You could also bring those in manually and show a certificate that it, in case you want to get certified for your final number, you can show evidence from your utility provider what their emissions are for their electricity mix.
Is it publicly available? Like, I would.
So it's not a public. We're a nonprofit, but the calculator it's not publicly available. You have to pay for it to use it. We're a nonprofit funded partially by the Swiss government. I'll send you the info on chat so you can see those.
Awesome, thank you. That will be very helpful.
So, and also believe if we contact the carbon modeling Workstream, led by Vijay and Deborah, they were looking at the carbon calculator too. And my understanding was they were trying to create, in fact, they were doing some POC or demo was available, but I don't know where is exactly where the state of that. So if you want to look at the OCP calculator, you should probably reach out to either Deb or Vijay.
Yeah, I had developed one in the past several years back, which is for, say, you want to build a 30 megawatt facility, and it builds a node, a rack, and the whole data center, and then also it has embedded all the cooling technologies, and it calculates everything, and then also all the software metrics, and then also the carbon emission, and then has embedded all the 50 states within US. What is the emission rates and all those stuff? It takes all those stuff and calculates whatever you need, right? So we have those.
So how can, is there a place to read up on it and follow up? Are you the one responsible for that?
Yeah,
or?
I'll check with the teams and see, because I developed almost like 4 years back, and then
Okay.
so I need to dig through and see, right? So definitely, yeah, I'll circle back. Yeah.
Because all I'm looking for is to make sure we use the right models in our estimate.
Sure.
So coming back onto the discussions today, what we are really looking is another item here. In fact, we want to have a panel discussions on how are we going to use the metrics to influence sustainability. That is one of the things we want to have. And also part of the IUE white paper, we want to put some kind of breadcrumbs on like, hey, why are we developing this metrics, right? How is it going to be helpful? And what is it going to influence, right? So if you look at the PUE, the way it is defined is you can say like total energy is coming into the data center to how much energy is going to the IT equipment. at least at a simplest form, right? So if you move some of the cooling related energy to the IT equipment, that is not counted in the PUE. And what we are doing in so in the definition on IUE, and just want to kind of recap so we can go back on discussions here, right? So what we are saying is take IT equipment. Even if you take IT equipment, it has you can say like there is a power conversion loss, thermal loss, as well as ideal power loss. So we are kind of zooming in into the previous one here, right? This whole thing is loss, and how much energy is going in to the IT. That is what PUE is. In the IT equipment side, what we are saying is, yes, there is also non-IT energy, that is power conversion loss, thermal loss, and ideal power. And the remaining power only goes to the computational side of it. Either you can call computational or real energy to do the real operation, like it can be network or can be storage or anything, right?
So, Sami, I have a question. The computational power also has a thermal dissipation, right? So I think the way one should look at it is probably the computational power, the green rectangle you have, then gets split into, becomes all yellow because that goes into thermal power, correct? Or am I?
Correct. What we are saying is, in another way of saying is, if you can do a supercomputing with less power,
Right.
right? Then
Exactly.
you don't have any thermal loss at all.
Exactly.
Or,
Exactly.
right, even if you have thermal loss, if you're operating in geographics where it's you're not spending power to cool that, right?
So this,
Then you're basically not using energy to cool the thermal.
yes. So then let me ask you this question.
Right.
The thermal power that you have now, what you classify as non-IT power, is to get
Right.
the power from the transformer to the machine. Is that where the loss is?
No, there's fan, right? If you look at the IT today, fan itself consuming more than 10 or 20%, right?
Oh, so this is the
Instead of
cooling
using,
also? Does it include cooling or non-cooling?
it's cooling.
Oh, I see. Okay, so this what you call as thermal power is the energy it spends to cool after computation or before computation.
After computation.
So then why are they not equal? Why is the computational power not equal to thermal power? Because all the computational power goes as loss, right?
But do you need to spend energy to cool? That's what it is, right?
Yeah. So that's heat.
So do you need to use fan?
Right.
And if you're operating the data center in a place where you don't need to use a fan or anything, it goes to environment without spending energy.
Right.
Then your fan that you are using to cool, or if you instead of using fan, if you use a immersion cooling, your energy that you're going to spend to kind of cool is going to be lower, right? Compared to air cooled.
Yeah,
I agree with you. At the end of the day, power has to equal.
Yeah.
Somebody has to spend the power.
Right.
But
Unless you have a, see this, I'm speaking at it because I don't know the details of the metric. That's why I'm asking these questions. To me, unless you recover the second law, right? Unless you recover the from the thermal power with the heat engine,
Mhm.
all the
Okay.
computational power should be equivalent to the thermal power, because you need to send the heat into the surrounding. So what you're operating is taking the higher temperature energy and dumping it on the colder environment.
Correct. But the thing is, if I operate a data center in, let us say, Singapore versus Ireland,
I see.
you're still using the same energy, right? But are you going to be using same energy to get the same performance?
So a
Assume
cool,
ISO data center, right?
so okay.
ISO equipments.
Yeah, so there is no recovery. That's my question. You're not recovering any energy. It depends on
If you
your
recover,
geography.
then it will, yeah, then if you recover, your non-IT power consumption goes down, right?
Okay. And your
All the
point,
thermal power, if you able to recover,
okay,
then it becomes zero, right?
I see. The problem is I can't see it becoming zero. It is limited on the maybe if I look through your numbers, it'll help me understand it. Because I'm seeing it as an energy balance problem. The computational power generates heat, and that heat has to be removed. And your argument is, depending on the surroundings and the environmental temperature, how much heat will I have to remove is actually lower in a cooler place like Ireland, as opposed to a hotter place like Singapore or Chennai or something.
Yeah, you're right. How much from grid, how much power you are taking, right? I know if you look at the energy side, it has to be zero sum game, right?
Mm-hmm.
Theoretically. But how much energy you're spending on not to do the computation, you're going to take some power. And in order to cool that computation, you're going to take some power, additional power, right?
Mm-hmm.
So if you reduce the additional power you're going to consume for the sending the thermal out, right?
Mm-hmm.
Then you're basically at least reducing the power consumption, right?
Because the environmental temperature is lower.
Good.
Is that the reason?
Either environmental or the method you are using, right? Today, even if you take a fan, right?
Mm-hmm.
You could take a smaller fans and it will consume a lot of power because you have to do a higher RPM. But if you took a larger fan, with the lower RPM, you get the same CF from the airflow, right?
Oh, I see.
So the energy you spend for the fan itself, depending on what you're going to use, is going to be different, right?
So what is the conversion efficiency of fans? Is that what do you use to make these conclusions? Do you have those numbers? Or?
It's we have not gone to that detail of exactly what is causing those things, right?
Okay.
At least what we know is fans are consuming power.
Okay.
Depending on your fan design, and then you may be consuming lower or higher, right?
Right.
And you want to push for a lower energy consumed fans. That means you may be a larger fan. It gets the same CF from the flow rate of airflow rate versus a smaller one. But if you go with a smaller one, it's compact and small, and people, I mean, you're able to densely pack the things, right?
Okay. Okay, so it's a more like a fan design or a cooling system design.
Correct.
Of how much. So that is essentially the amount of energy that can be removed for a given amount of power the cooling system needs, it looks like.
Yeah, if you're
So
just think about
yeah,
right computational power. Just minute, wait. The fan power, in order to cool the computational power also, you're going to spend extra energy in the fan to remove the computational power, right?
Mm-hmm.
And that extra energy going to the fan, again, it's wasted energy, right? And why we need to have the extra energy? Can we make this things zero? That's what our argument is here, right?
So
Or
if
not
it is,
zero, ideally lower.
no, I got it. I got it.
Good.
So if it is in a, let us say in a 0 Kelvin place, then in principle you can dump all the energy without any fans, is your argument, I think.
Good.
so Sadas, I also want to add that here we're trying to focus on competition. So I think this breakdown of power here is not scaling according to the picture.
Yes.
Most of the electricity, basically electricity goes into the server, and we want to create metrics for how effectively the actual electricity delivered to the computation how efficient it is, and create indices for it so we can measure it. Now, most of the electricity is now delivered to the servers these days because the PUEs are going down, hyperscalers go to 1. And in the near future, especially if you look at AI with liquid cooling, most of the electricity is getting delivered to actual computation. So I think Sami has this beautiful, colorful picture, but these breakdowns don't really scale according to the picture.
And also these are not drawn to scale, or are they drawn to scale?
No, not
exactly. That's what I'm trying to say. The visual is not drawn to scale. So
Yeah,
our focus here is mostly the green part, but he's drawn these labels so that the fonts are the same size, so they look like, these things are pretty bulky, but they're not. There's a very small fraction of actual electricity in the near future will go to all this other losses.
So that's why I think what we have to do is we have to use this all the formula, all the work we have done, right? We have to go and measure, take a measurement on different type of systems, right? Take a GPUs, CPUs, and multiple different vendors and systems, right? Go and measure it, and then you can figure out like, hey, yes, I see this wonderful change in the numbers, right? Then you can compare. What we are saying is, first come to a clean metrics of what are the things you can measure. Once you can measure, then what we have to go and influence to reduce or improve, right? And also, can we compare between the systems? Those kind of 3 things we are kind of looking like. First, get the metrics out in a way people can agree. Then you measure it. Then you can compare it. Even if you compare, we purposefully left out the performance part as part of this IUE metrics. Then also we said like, we have to start looking into the performance portion of it, because unless you compare the performance, people can argue like, yeah, I have older car versus newer car. It's probably consuming same amount of energy, but I'm going a lower distance, right? In the older car versus a newer car, right? And same thing argument for compute, right? A newer compute provides a better performance for the same energy, right? And then we have to start comparing performance person, how much performance you're getting out of energy that you're spending, right? And again, when you start walking into the performance, I think we sent some links a long time back. There's multiple ways, right? It's not a one single performance you can compare, because there's different workloads going on to the system, and you have VMs and in the same system, multiple different workloads running, right? How do you compare, right?
So These things I have addressed to some extent in one of the papers actually. You can
Good, I
try
think
to look
we'll
at the
have to-
different
yeah, we'll have
metrics.
to review that. Yes, yeah.
Yeah, it is. I just sent it to all of you, or at least responded to your email.
Sure, sure. Thank you. So now, going back with this background, I think what we are want to spend some time to like, what are the different angles we should be looking, right? So we know PE is one metrics, IE is another metrics, and performance per energy is we have to start looking into that metrics. We have not spent enough time in the OCP side. And also there's a carbon metrics being developed by systems, right? The OCP teams are looking, we are not aligned on a specific metrics. So if I take all these things, we are doing is we are just measuring what is we are getting out of it, right? And how are we going to influence to improve the sustainability? Basically meaning either we have to reduce the energy that is consumed, or we should reduce the wasted energy, right? All the energy goes to compute, or you should get a really good performance out of the systems, right? The amount of energy you are spending, you should get a better performance than what you're getting now. My question is, what we really like to aim for? Then we can say like, where we have to go and influence further, right?
So, Sammy, I have a couple of comments. One is that, so we've talked about this a little bit in the past, but PUE as it's defined does not take into account important changes to data center market, especially in Europe where there are heat recycling networks. So we need to be careful about using PUE. PUE, if we use it verbatim, it may refer to what was defined 20 years ago, and we need better DC energy flows than PUE, number one. Number two, if PUE and whatever the metric is and IUE are on the same scale, then an IT customer and a DC customer can, collocator can also combine their indices together using geometrically. I hope. I just entered the tunnel. I apologize.
It's okay, yeah. And understand we are traveling, right? So if I recap, what you're saying is PUE is not considering heat recycle.
That's correct.
So one more point you said.
Yeah, so PUE needs to be enhanced. We have an index, which is an integrated index. We call it PUE plus. We can define it in this group whatever we want, but it has to be a new term that takes into account also heat recycling. That's one point. Okay. Second point, if the IUE and PUE improved PUE index are on the same scale, then you can have a holistic index with the geometric mean of the two. That means that an IT customer and a DC collocator can combine their metrics to get one holistic metric.
Right. I think today PUE is not comparable. Specifically, they're saying don't compare PUE between data centers, right?
Why do they say that?
Because I believe my understanding is that you're not getting the same type of performance, or the location, depending on the locations, that things may vary. If you read a lot of PE definition itself, I think it's designed not to compare between data centers. That's what they're saying it.
So ISO has now launched a PUE equivalence for certification. The European Union is using PUE as an index for comparison. So these are now sort of being, basically they're launched, they're being widely used. And how you measure PUE, the methodologies to measure PUE, of course, have to be consistent. And these certifications, including ours, they specify what the proper methodology is for measuring. But once you measure it, it's comparable. Why is it not comparable?
Yeah, if we are using the same definitions clearly across the,
Exactly. If you have a proper definition for the metric and you have a proper methodology, which is followed, then it's comparable. It's the same thing with IUE. IUE, if you have a proper definition, you have a proper definition. What I was trying to say is that if you have a PUE for your DC flow and you have an IUE for your IT customer has an IUE, these two can also be combined because they're on a ratio scale, and the ratio scales can be combined using geometric mean.
There are
and
sorry. There are two other factors that are considered in data science. One is a factor called WUE, which is basically water usage and how much goes into cooling the site and is used in on the site, how much is used in the supply chain. So water usage is one thing that is considered. And another factor that is considered is the waste, like how much of the electronic appliances goes to landfill and how much is recycled and all of that. So two other metrics that are used is water and waste.
Savita, where are those metrics available somewhere?
So, yeah.
Go ahead, yeah.
Yeah. So EN 50600 is a certification that the European Union has launched. And it basically has a metric. It has PUE. It has a separate waste heat metric, and then it has a carbon usage effectiveness metric. And it also has a water usage effectiveness metric, as Savita mentioned. We in SDA, we integrate the waste heat metric. We actually do a heat conversion and bring it back into the PUE. So we don't measure it separately. We actually help the PUE. PUE gets better if you recycle a lot of your heat. But EN 50600 has a specification for that, and I think ISO also now has a specification for it. Some of these.
So if I can maybe summarize based on this one, right? What we are really aiming for is to recycle, right? Better recycling. And are we aiming for reducing the energy consumption?
Right.
At the end of the day, I think my question is, if we have a lot of different metrics we are defining, what we really want to see.
Right. What do geometry?
On the case-to-case basis, I think different data centers may care about different things. So, like if you go to where water is scarce, WUE may be way more important if you go to coastal area where there's plenty of water and they don't care about it. So, I think on a case-to-case basis, we need to pick what metrics is important. That's my understanding from my experience here.
Yeah, so yeah, even if you look at water, right? What is the black water, like multiple different metrics? How are they accounting for it in under PUE? Does matter, right? If you want, again, I think Babak said, like India proper definition, everybody need to be comparing the same thing, right? And also, I agree with you, Savita. It's depending on where that influence may be higher or lower, right? If the water is scarce, then you really like want to make sure that you are conserving it. If you have a lot of water, then probably in that area it does not impact that much, right? So what you're kind of saying is geo is important. Geo plays a role.
Yeah, but I right. So
Good. Want to say something?
the WUE are that is that information available somewhere?
Yeah. There's a lot of definition. In fact, when we started working on IUE, we started writing a white paper. We were
Okay.
trying to kind of say like, hey, there is what is the impact on, or the way we were putting is, what are the opportunities for us to OCP to start working and improving? And one of the item is like, if there is a WE concerns, that how it's getting accounted also matters. And I think there's a WE definition. I can look at it and send you a link. What are the
Yeah,
different
it's captured at many places, yes.
Yeah.
Yeah, I'm just posting a Schneider white paper, which has the definition of UE if you want it.
Okay, thank you. Thank you, sir.
Yeah, I think so. Yeah, maybe probably also we are running top of the hour. So start thinking about it. Hey, what is the different areas that we want to influence, right? The reason I'm kind of looking for is kind of twofold here, right? We really need to articulate what is this metrics going to influence and contribute to the sustainability. We have to tell how this is going to influence. So that's one of the reasons I want to get some initial thinking as a group to say like, hey, where we want to use this metrics and where we want to influence it to make a change.
So when you say influence in the sense, companies like Intel or the data center companies, right? The customers, Intel customers are the ones whom you are trying to influence?
Both sides, right? So now we started putting EPE and government started noticing that your efficiency, data center efficiency is lower, and they were mandating, like if you look at the EU side, right? They're trying to like, hey, you should operate a data center with a PE number of, I don't know. There is a number that mandated, so the people are trying to kind of get that lower number, right?
And then also
and
they
also,
get, oh, sorry, go ahead.
Good, could be, yeah.
There, in the future, when the energy policy making decisions are made to promote the liquid cooling aspect of it and immersion as the time passes, and there'll be some potentially opportunity for the policy makers to provide carbon credits and all those stuff, as long as they publish validated, certified, metrics, right? So there's another thinking, which may happen.
Yeah.
Go ahead, sorry.
Yeah. So I think that's where, right? I think we really need to kind of go back. I want to kind of go back. This is a two area we said, like in our group, where in our work stream, we want to spend some time to kind of complete these two definition. I believe IUE we are kind of getting closer to saying that all the parameter required for IUE we have it. We need to write it down and get it reviewed. And this is the next area we want to start spending time and say like, hey, what does that means, and how do we use the OCP to defend that? But even with this, I'm kind of trying to say like, hey, what is it finally we want to influence? Where are the things where we want to influence it here, right? And carbon and other things. It's work is going on. People going to talk about it, but we can summarize that. What is it they're going to influence there, right?
Yeah, the metrics, measurement methodology, real-time analytics, and publishing common metrics as an industry. Those are all the key important elements in a way, right? As we move forward.
Right.
Because just publishing I'm at PUE 1.05 without any relevant data behind the scene, it gets harder to know what really happened here, right?
Correct. What type of optimizations they have done to reduce that, right?
Right.
Okay, so yeah, please think about it. Let's probably bring your thoughts back. So let's have one more discussions on this, and let's summarize it next week.
Sounds good.
And after that, what I would like to do is just I will also put some thoughts and start putting the IEE, all the definitions that we have worked so far for us to final review. And after that, we start spending some more energy on the performance per energy definition.
Right.
What is the OCP take here, right? I think that we need to spend some time and conclude.
Yeah, sounds good.
We will do that after 2 or 3 meetings after that. Yeah. Okay. Sorry, we went over. Thank you, Tim. We will talk to you next week.
Thank you.
Thank you, Sami.
Thank you.
Yeah.